other questions? So let's carry on. Explicit is better than implicit. So this is also coming from our Python. Import this Easter egg. Tomorrow is Easter. Good thing we talk about Easter egg. And that's the second statement that we have in that very eloquently written Zen of Python. So what is implicit? Everything that you imply is implicit. I could also say whatever you're assuming is implied or implicit. So it's better to be explicit. Explain yourself. Don't just assume that somebody is going to enter a value that's not 20. We want to explicitly know that it's greater than, less than, or in this case, equal to, which is why we have chained conditions. In a chained condition, we'll introduce the elif word or the elif statement. Elif is short for else if. Okay. So for instance, in this example, if we are going to compare the value of x and the value of y, if x is less than y, we can print less. Otherwise, we go ahead and check if x is greater than y, then we can print greater. And then the third option then would be equal to. So let me escape out of this and take a look at the code that we had written earlier. So in our code that was written in Visual Studio Code, we went ahead and said if A is greater than B, then we should say A is greater than B, else it's smaller. Now, if we will execute this one more time, we did earlier and enter the value of 25. We said 25 was greater than 20. But if we want it now, and we enter a value of 20, it tells us that 20 is smaller than 20. There is no way that is possible. So what we need to do is update this code. To update it, we need a third option. So rather than having else, we want to do else if. Else if is written as elif. But in Python, we want to be able to keep things simple and not waste characters and space. So now we know that if A is greater than B, we print that it is larger. L if A is less than B, then we say it's smaller. When we use the L if statement, we need to conclude it with an else. Oops, I need to go one more. Now we can say else print A and B are equal. Everybody okay with that? So in this case, we made sure that we change that to elif. You see else, and so on and so forth. Okay? Does that look good to everyone? So now that we've gotten this, let me show you a few features in Visual Studio Code. In Visual Studio Code, when you see a white dot right here, when I move my mouse there, it becomes an X. When you see a white dot, that means you have not saved your changes. Okay? That means you have not saved your changes. If I go ahead and save it, I'll do Control S or Command S to save it. Now that white dot is gone. Now we see our X in there. So that's a quick way you want to note if you have made changes. That's the first thing. The next thing you'll see is that now we have 4 showing up in here because we have added this this folder to our GitHub account. Okay, so if I click on it, it shows me that there are 4 changes. Or if I hover over it, there are 4 changes. What are those 4 changes? You can probably see them in here. This is showing you that a change has been made on this line. This is showing you that this line has been added. So if I had given you this code and I went away and came back, I should be able to see those changes on there. And it's showing me that the changes are in one file. That file is the file that we currently have open. Let me drag this so we can see. So it's in this file that has been modified. It's showing me that this file has been modified. These other files have been added, but this is just the staging area. I can go ahead and commit them. All those other things we can talk about. It has nothing to do with Python. Everything I'm talking about now has to do with your source control, which is GitHub. But it's good that you see all those things and it makes sense to you why all these colors are coming up. Okay, so everything on our local machine is good. But if we want to push it to the cloud, if we want to push it to GitHub repository, then we can go ahead and commit and push and do all those fun stuff. But for now, let's concentrate on our code. We've made these changes. Now we should be able to get something that's accurate and not saying that 20 is smaller. So let's go ahead and execute that. It comes up and asks us for a number. I enter 20. Now it says 20 and 20 are equal because we've gone ahead and captured that fact that A can not only be greater than B, it can also be less than B, or it can be equal to. Sounds good to everyone?
Yeah.
What questions do you have? So that's one way of doing it, right? Let me copy this over and switch back to Jupyter notebooks so we can play with it as well. It might be getting lonely out there now, so let's go check it out and see what it's up to. So our Jupyter notebook, this is day 3. Let's go ahead and add the code that I've copied over. Did I copy it? No, I did not. Let me go back and copy it and then paste it. Okay, so that's our code that we had in there. So we talked about chained expressions. We could have also nested that expression. How do we go about nesting an expression? To nest the expression the same way, you can have a yes or no. Start by is A equal to B? If yes, we go ahead and execute that equality sign. If it's not equal to B, then we go ahead and check if it's less than or equal to. So that would be a nested group. You have an if statement inside an if statement. Okay, so how do I do that in this case? Let me escape and go back to Jupyter. In here, I'll start by saying, I don't want to type too much, but I also want to make sure that you guys see clearly what's going on. If A is the same as B, make sure that you're using 2 equal signs. Because if you're using 1, that's an assignment operator. If you're using 2, that's a comparison operator. So if those 2 are the same, then I'll go ahead and print A is equal to B. Otherwise, I can go ahead and do 2 things. Now this becomes a nested statement where I can have another if statement inside that else block. So inside that else block, I have another if statement that will say if A is greater than B, then go ahead and print A is greater than B. Make sense? And then now we can have our else say A is less than B. So it all depends on you which one is better to write. Okay, so in here I've written this. Let's check it out again. We're going to say A is going to get the value that we're going to enter. make sure that it's converted to an integer and it looks good, but we're saying b is going to be 20. First, we're going to check if the two values are equal. If it is, you're going to print a is equal to b. Otherwise, we're going to have a nested if statement inside, or a nested if-else statement. So we check here, our condition is a greater than b? Then we say a is greater than b. Otherwise, there can't be any other option. If it's not equal, if it's not greater, it has to be less. So we can just use our else in there. So if I execute this, it's asking for a number. Let's say 21. 1 is greater than 20. Let's execute it again. It's asking for a number. 19. Let's say 17. 17 is less than 20. And let's execute it again and put in 20. 20 is equal to 20. So that's how you conditionally execute based on what value is entered. Looks good to everyone? Questions, comments, concerns? So it's very easy to make mistakes and errors, right? If I go ahead and I forgot to write this as a conditional operator and I wrote it as an assignment operator and I execute it, it's already telling me you're speaking gibberish. You have to go back and learn your ABCs, right? Remember, Python is a language. It's normal for someone that does not know French to speak broken French. This is broken Python, right? It's normal for someone that does not know Spanish to speak broken Spanish. In this case, again, we have a syntax error. If you don't know Python, if you're not familiar with operators, arithmetic operators, assignment operators, comparison operators, logical operators, then you're going to have a hard time understanding what this is. It can be a turnoff and discourage you from writing code, but all you need to do is go ahead and change that from assignment operator to a comparison operator, execute it, and you're doing good. Sounds good to everyone? Next problem is when you have troublesome people like myself, instead of them entering a number, they go ahead and type in ABC in here. If you type in ABC, get an error. Invalid literal for int ABC. It does not know what that is. That is a traceback error, okay, based on the value. So we'll talk about that next. Just want to emphasize again, we've looked at chained and nested expressions. A chained expression, you have if, else if, or elif, and else. In a nested operation, you have if else, or if elif, or whichever combination of those within an if statement or an else statement. So you have to understand which way is the best way of doing it. In programming and in anything in life, it's always good to have a plan. So that's why it's good to draw out these flowcharts. When you draw out a flowchart, these diamonds always mean a condition, and it's a whole process to talk about each one of them. The rectangles are usually a piece of data, and so on and so forth, and the arrows tell you the direction to take based on a decision or the instructions that we're following. And next thing that I also wanted to point out is short-circuiting. So Python does not like wasting its resources. If it's going to compare two, or if it's going to have multiple expressions, once it evaluates the first one and it sees that it does not meet the criteria, it goes ahead and skips the second one. What do I mean by that? If I were to go ahead and say, let me write this query, say if A is equivalent to that, and let me say, or A is equivalent to 3, and you can print that. So this is an example of an OR operator. OR operator, you need at least one of them to be true for it to be true. So in Python, once it evaluates this first one, let me put them in parentheses so they're all clear. Once it evaluates this first one and it's true, it knows that the entire expression is going to be true. Python is going to go ahead and skip the rest of that and go ahead and print this already. Okay, so let's go ahead and try this out. If I execute it and type in 3, I shouldn't type in 3. That's fine. Let's go ahead and do 20. It's going to automatically not execute due to pending input. Oops, I was supposed to go ahead and press enter. It goes ahead and prints out 20. It doesn't really care about if A is 3 or not, because it's short-circuited in this case. It stops executing at this point in time when you have evaluated the first one and it's okay. Okay, so just take note. In some cases, you might want to have certain expressions in the front and other expressions in the back, depending on how you want to optimize your Python code. So those are sort of things that might be useful for you if you get into an interview case and they'll ask you how can you optimize your Python code. You can use short circuiting. Okay, most people that will probably interviewing you might not be aware of it, and that will make you sound very smart. If you say, okay, the way I would like to optimize my Python code is to use short circuiting so that all my sub expressions that are more vital should be executed first, or should be evaluated first, before the other ones that are less predominant are evaluated, so that if it evaluates true or false, I can carry on and save myself a few resources here and there. Okay, so that's what we get with short circuiting, and we talked about nested as well as if-else statement or chained elif statements. Let's proceed. Next up is error handling. Like I said, when we're converting input, like we've seen in this case, we get an input from the user and then we use the int function to cast it. Sometimes we might get error messages. I've shown you a few of those error messages, like a traceback, maybe a value error. There are many different types of error messages we can get. In some cases, maybe you're trying to open a file, right? You can use Python to open a file in your folder. If the file is not there, it's going to give you an error message saying file not found. Maybe the file is there and you don't have permissions to even open it. So you want them to be able to say, hey, file is there, but you don't have permissions, and so on and so forth. So in that case, you use a try block. Okay, the try block actually contains code that has a potential to give you an error message. So you try that piece of code. If the error message comes up, then you have an except block. This except block shows a code that runs when that error or that condition happens. There are many different types of exceptions too. You want to be specific, for instance, a value error expression, file not found expression, a divide by 0, and so on and so forth. So when you find that, you want to give specific answers that will help the user, or also help the programmer to be able to debug, to be able to find out where the error resides. In some cases, you might want to just raise an expression. So for instance, if you're checking the water value in a sewer, say you work with the waterworks department, if you're checking that value and you need it to be a particular value, once you check and that value is not met, you want to raise an expression and just say, hey, error. You want to make sure that there's water in the pot before you start boiling rice. Otherwise, you're just going to burn it. Okay. So a few of those examples, let me go ahead and demonstrate that to you. Let's go back to here. So if I went ahead and did execute this and type in ABC, I did get that error message, value error. The way I need to be able to fix that is by doing a try catch. How does a try catch work? I go ahead and do try in case of getting this value. Where is it? So the best thing I'll do here is I want to just add input. Yes, question. Okay, yeah, sorry about that. I thought that was a question. So someone did have a comment that if there's no water, it's just fried rice. Okay, so I thought you still use water for fried rice. How is the rice going to boil if there's no water in it? You need some water at some point, right? Anyway.
Not sure. You can try that for Easter. I don't know.
You want me to burn down the house, man? Okay, so again, in this case, you want to be able to try this out. I think what I want to do then is maybe refactor my code. Let's say I'm going to call this user input. The user input should be equal to everything in here. So user input should hold everything that they enter, and then I can go ahead and convert my user input to an integer that way. Okay. So now this is the part that I really need to try out to make sure that they enter something good in there. So in order for me to do that, I'll use the try keyword just like that. I try, I'm going to try this value out. Is everybody with me so far? Yep. Okay, so I'm trying that value. If the user does not input a number, then I can go ahead and do an except. Shouldn't add an extra line. Let me put everything concisely. Except I can go ahead and give them an error message. Print is cannot spell. Is enter a number. That should be all good. Okay, is everybody with me so far? So let's go ahead and try this out. Okay, so the last time I entered ABC and it gave me this nasty looking error. Now I've gone ahead and made my user input to be in a try catch block or try catch exception, being able to handle that error. Let me make this smaller so that we can see the whole code actually. There you go. If I execute this, that's for value. I'm going to enter XYZ. Enter. I don't get that error anymore. It tells me please enter a number. And since that value is XYZA is not yet assigned, if it checks this, it gives me that. Okay. So again, all of that has to be in there. For instance, I need to go ahead and probably get all of this to make sure that it does not execute and put it in here. I want to go ahead and tab that in there to look like that. So it's going to try this all out. And in this case, JJJ is going to tell me, please enter a number. But if I entered a good number like 26, it tells me 26 is greater than 2. Looks good? Everybody okay so far? Questions, comments, concerns?